In today's video, we are going to be talking about lenses. And after watching this video, you should be able to tell me the anatomy of a lens, determine the refraction caused by a lens, and determine the image formed by a lens. Okay, so let's get right into the good stuff. First question is, well, what the heck is a lens? A lens is basically a ground or molded piece of material, whether it be glass or plastic, that refracts light in such a way as to form an image. And so lenses are used in things like glasses, microscopes, telescopes, all that good stuff. Basically, a lens takes light and focuses it in a way that is useful. Okay, so whether it's magnifying something, shrinking something, whatever the case may be. There are many different types of lenses, but in this course we're just going to be focusing on two types, convex and concave lenses. And so you guys are clear, a convex lens looks something like this. All right, so it's typically fatter in the middle and thinner towards the top, whereas a concave lens is actually just the opposite. It looks thin in the middle and fatter towards the top and bottom. Okay, so that's a concave lens, and then a convex lens is right here. Okay, so let's talk a little bit about these guys. A converging lens is the very same thing as a convex lens. Okay, so don't get that mixed up. This is a convex lens. Okay, is a lens that converges rays of light that are traveling parallel to the principal axis. Okay, so a converging lens would be something you certainly could, like, take a magnifying glass and like melt a stick, or not melt a stick, but start a stick on fire. Okay, it would cause the light to converge at one point and kind of amplify it, if you will. A diverging lens, which is the same thing as a concave lens, is a lens that diverges rays of light that are traveling parallel to the principal axis. Okay, so in a nutshell, here's a converging lens, and as this light hits this lens, in general, the rays are going to kind of converge together. Whereas a diverging lens is going to do just the opposite. As it hits this lens, they are going to bend and separate in opposite directions of one another. They're going to diverge or separate. Okay. Just a quick vocabulary recap from our previous unit. A line passing through the center of a lens is still called the principal axis. Okay, so a lot of the vocabulary that you were using in the previous unit will still be used again in this unit. The intersection of light rays is called the focal point. Okay, so where the light rays intersect is called the focal point, and typically every lens has two possible focal points. Either on the left or right side are possible focal points. Okay, so let's talk about the refraction of a converging lens or a convex lens. Okay? As light travels towards a lens, it moves from a fast medium to a slow one. And if you remember in the previous unit, I talked about using this mnemonic device, if you will, where F is fast, and that's the medium through which the light is traveling through. S is slow, and then T stands for towards the normal. Okay, and if I just take a look at this ray of light right here, as it hits this lens, and it's going from a fast medium to a slow, or relatively slower medium, and here's the normal line, this dotted line. Notice this red line bends towards that normal. Okay, so it's following those same rules of refraction that we talked about before. And then as the light exits the lens, it's going from a slow medium to a fast one, and so it's going to move away from the normal line. And so here you can see this red line, it hits this hits the edge of the lens, and here is the normal line, and it is moving away from the normal. Okay, so those rules still apply. They're still fair game. So if you're doing well with those, good, because it's helpful to use them. Okay, and then the light will converge at a point, and that point will be called the focal point. All right. The first rule to converging lenses for understanding how the light rays refract Basically, any incident ray traveling parallel to the principal axis of a converging lens will refract through the lens and then travel through the focal point on the opposite side of the lens. Okay, and basically just kind of like how there were rules with mirrors and drawing ray diagrams, that's what we're working towards here. Now I will have other video lessons on drawing ray diagrams in specific, but that we're just kind of setting the framework, the boundaries, if you will, on how to draw these diagrams in this video. Okay, so this rule basically says that any incident ray traveling parallel to the principal axis of a converging lens will refract through the lens and travel through the focal point on the opposite side of the lens. The second rule basically says that any incident ray traveling through the focal point on the way to the lens will refract through the lens and travel parallel to the principal axis. Okay, so those two rules are probably the easiest ones to remember, and so that's why I kind of focus on them. So do what you need to do to remember those rules. These are the rules for a converging lens. Okay, so that's going to be important because a diverging lens is going to have a little bit different set of rules. All right, and we'll do a quick practice problem with using these rules right now. Okay, so I'm going to set up my converging lens, or draw one, I should say. So here it is, and I'm going to draw my principal axis, and I'm just going to make this up. Here's a focal point, and here's a focal point. Okay, and we'll say here is my object. Okay, and I'm again represented by an arrow. Okay, the first rule said that this incident ray, which maybe I'll change colors if I can. Let's see here. Let's go with red, just to change it up a little bit. This incident ray is going to travel parallel to the principal axis, okay, which is this line right here. Okay, so it's traveling parallel to the principal axis, and then what it says happens is, as this light ray refracts through the lens, it's going to go through this focal point over here on the right-hand side. So it's going to go through the focal point right there. And again, a ruler is helpful for these problems. You can see I didn't quite go through the focal point exactly, but that's about as good as I can get. Okay, so that's rule one. Rule two says the second incident ray can travel through this focal point, hit the lens, and then it'll travel parallel to the principal axis. Okay, so I'm going to do that. Try to go through this focal point. I'll miss it a little bit, but not too bad. Hits the lens, and now it's going to go parallel to this principal axis, and so it'd be somewhere like here. And you kind of see these two light rays are meeting, so our image would be here-ish. Okay, but that's really not what we're after today in today's video. I want you guys to practice these rules, getting these rules in your head so we can draw more ray diagrams. Okay, so that's what those two rules would look like for a converging lens. Now let's talk about a diverging lens, and remember, a diverging lens looks something like this. Okay, where it's thinner in the middle, okay, and the light rays diverge once it hits the lens. Okay, so here's rule one. Any incident ray traveling parallel to the principal axis of a diverging lens will refract through the lens and travel in a line with the focal point. And basically what I'm saying is, in a direction such the extension will pass through the focal point. And this sounds really confusing, but just kind of write it down, hang with me, and once I get to the example or I can draw the picture, I'll show you how this kind of looks. Okay, but basically any incident ray that travels parallel to the principal axis will refract through the lens, and then if the ray tracing going backwards will lead to the focal point. Okay, and again, a picture I think is worth so much more than these words written right here. Okay, so that's first rule. Second rule is any incident ray traveling towards the focal point on the way to the lens will refract through the lens and travel parallel to the principal axis. Okay? So those are the two rules for a diverging lens. All right, and I highly recommend remembering these because it's going to be super useful for when we start doing ray diagrams of diverging lenses. And again, I'm going to have a whole video just for diverging lenses and ray diagrams. So don't worry too much about that right now. Just basically get these rules down. Okay, so let's practice a little bit here. Okay, so I'm going to draw my principal axis. Here is a diverging lens, which is relatively big looking, okay? And I'm going to draw a focal point here, and I'll draw a focal point here, okay? And then I'll draw my object right there, okay? So the first rule says that this incident ray is going to travel parallel to the principal axis. And before I start doing that, I again will change my pen colors just to kind of keep things organized. Okay, so this first incident ray is going to travel parallel to the principal axis, and once it hits this lens, it's going to diverge in some direction upwards. What direction? Well, if I trace back to the focal point, and this again is where a ruler is super helpful, I can, and I'm going to do dotted lines here, I can kind of draw a dotted line, and then once I get to this line here, I can then extend it as if I trace this back, it would go through the focal point. And that's I believe, the kind of confusing rules. Like, what was I just writing before? Well, that was this in written text. Okay, so incident ray, parallel to the principal axis, hits the lens, and then if you trace back through the focal point, you can then extend the line. Okay, so these dotted lines aren't actually a light ray, it's just kind of your imagination, if you will, tracing back through the focal point. Okay. The second rule says that it will travel towards this focal point over here, and then it'll start heading parallel. And this is going to be really tough for me to do, but I want to try to get it in a line that's traveling towards that focal point. All right, so I will see what I can do. That's not too bad, I guess. Okay, towards this focal point, and then once it hits this lens, it's going to head parallel to the principal axis. And you'll notice these two light rays, they will never intersect, right? They are what's called diverging, okay? And that's why these are called diverging lenses, okay? And if I were to want to know where does the image actually form, I could trace this line back, and where these 2 points meet, here would be my image, okay? It would be over here. Okay. But again, that's not really the point of this video. We're just looking for how to draw incident rays. Okay. Now, here is a picture of basically what I just did of a diverging lens. Okay, so on the left would be the second rule. Okay, oops, my fault there. On the left is the second rule, where this incident ray is traveling towards the focal point right here, but once it hits the lens, it then goes parallel to the principal axis. Okay, so this would be the second rule. And over here, we have the first rule. Okay, so clearly I put these in order. But basically, this one, it's traveling parallel to the principal axis. It hits the lens, it refracts outwards, and if you trace this ray back, it heads back into the focal point on this side of the lens. Okay, and that's the first rule. Okay. So let's say you're not really a big fan of one of those rules. Well, there is a third rule that works for both converging and diverging lenses. Okay, and so it's a common rule, and this one might be the easiest one to remember. So maybe use this rule. Any incident ray that passes through the center of a lens will, in effect, continue in the same direction that it had when it entered the lens. Okay, so here you can see here's an incident ray traveling, and it goes right through the center of the lens right there, and then it just keeps on going its merry way. Same with this one here. Incident ray goes through the center of the lens and keeps on going through its merry way. And this works for a converging lens, and it also works for a diverging lens. Okay, so that rule is common between the two lenses. Now, just some quick rules on image formation. Remember, only 2 rays are needed to form an image. So I gave you guys 3 rules. Pick your 2 favorite, and I would stick with those for both converging and diverging lenses. And then you'll be able to draw ray diagrams with relative ease. Okay. One thing to keep in mind is converging lenses can produce virtual and real images. Okay, so it can produce both types, whereas a diverging lens can only produce virtual images, which is kind of good to keep in mind because as you start doing problems and stuff, if you're trying to solve a ray diagram for a diverging lens and you're getting a real image, well, you probably did something wrong, and so you'll want to reconsider that and maybe try again. Okay, so that takes care of today's video. I will see you guys next time.